All right, so we are kind of starting the last concept today that we're going to spend this week and next week on, because there's a lot of different versions that we're going to see. But if you take a look at lesson 7.5 today, there's two lessons left, 7.5 and 7.6, but we're going to take our time on it. We're going to be starting now solving equations. And so specifically today, we're going to go back to exponential equations, and I'm going to try to break this up a little bit. Today, tomorrow, we'll talk about exponential equations and how to solve them and practice it, so hopefully you got that down. Next week, then, we'll get into logarithmic equations and how you solve ones that have logs in it. And then we'll take a day where we kind of put it all together, okay, including like natural logs and stuff like that as well. So we'll do a little bit of everything. That'll take us to the end of next week, and that'll take us to the end of the chapter. And then the following week will be review and test on the chapter. So just kind of a heads up at where we're at. So if you take a look, if you go to the note sheet, we're going to go right into the notes and how do you solve these types of things, and get into some examples. And so here's the main idea right here. Whenever you recognize an exponential equation, okay, which first off, by the way, if you have an equation, how do you know? How do you recognize that it's exponential? How can you tell you have an exponential equation? What's the giveaway? Because that's one thing you got to be able to know. Where's the variable located? Where is the variable located? Not on this now. Don't get confused with what you see on the screen. I'm talking just in general. When you look at an exponential equation, where's the variable always? Think back to when you were graphing exponential growth, exponential decay. Come on. We can't be 2/3 of the way through a chapter and you have no idea what an exponential equation is. Parker, what do you got?
It's in front.
You can move an exponent in front.
It's the x, it's the square root. It's not square. It's the exponent.
There you go. Got it. As you go through, it's the exponent. When the variable is up in the exponent, that is an exponential equation. And therefore, that's what we're going to take a look at today is how do I solve those? So those 2 to the x, 3 to the x, 4 to the 5x power. Okay, anytime there's an x, anytime there's a variable that you're solving for that's up in the exponent, that is an exponential equation. And we're going to talk about how we solve all of those kind of problems today. Okay? So, option number 1. And we've already done option number 1 a little bit in the last couple of days. If 2 powers can be rewritten with the same base, and what that means is their exponents must be equal. Okay, we did that the other day on some of those sheets where we said, if they're both base 2, let's rewrite them as base 2 and therefore set the exponents equal and solve from there. If they're both base 5, let's change them both to base 5 and go from there. So option 1 is if you can rewrite them both as the same base, then you can go through and solve it that way, and I'll show you an example like that as well. If you cannot do that, then we go to option number 2. Okay? If 2 powers cannot be written with the same base, then you're going to try to get the exponential term by itself. And what I mean by exponential term is the base raised to the power. And you'll see what I'm talking about, like the 2 to the x, the 3 to the x. If you can get that by itself, then we're going to use logarithms and some of those properties now to solve. Okay? Some of those properties that we've been working on. And so, if we take a look, here's example number 1. Okay? This one hopefully is fairly straightforward. I'm going to show you a couple different ways to do this one. And you can kind of decide which one makes more sense. So option number 1, when we go through and solve this, take a look at the bases that we've got here. We've got a 2 and a 4. Can I rewrite those both as the same base? Yeah, they're both powers of 2, right? Okay, so therefore, when I rewrite this, I can start with, leave the first part alone, 2 to the 3x, but then I can rewrite 4 as 2 squared, and therefore, now we can take a look, and now since the bases are equal, now the exponents have to be. And therefore, I don't have to worry anymore about the bases being 2. I can go straight to the fact that now 3x has to equal 2 then. And what I'm looking at here is I'm just looking at the exponents. Those parts have to be equal. Bases are already there, so now the exponents will be. And therefore, if 3x equals 2, divide both sides by 3 to solve for x, and there's your answer. X equals 2/3 in this case. If you're solving that equation. Notice, by the way, exponential equation, I probably should have started with that because of the fact that the variable is in the exponent. Okay, notice we've got a 3x up there in the exponent. So there's option number 1. You could go through and just rewrite these as the same base and then solve the exponents. Option number 2 is, if you take a look, we could rewrite this problem in using the definition of a logarithm. So if you remember, there was some earlier last week, we went back and forth between logarithmic form and exponential form. Okay, so I could rewrite this as, if I wanted to, the log base what? Base 2, okay, because the exponential part is base 2. The log base 2 of the 4. And remember, it always equals, it always gives you the exponent. So in this case, it would be 3x. So if I took this exponential equation and rewrote it in logarithmic form, I have that. And now if you take a look, what's the log base 2 of 4? What's the log base 2 of 4? What does that equal? 2. All you're asking is, in this case, what do you raise 2? What power do you raise 2 to get 4? Okay, 2 to what power gives you 4 is really what that's asking. So this equals 2, and now you're right back to the 2 equal to 3x that you had over here. Okay, 3x equals 2. This part that you had right here is now the same exact thing that you have over there. And then once again, finish out the equation. Divide by 3, and there's your 2/3 right there for your answer. Okay, so you could use the definition of a log when you have the same base. It kind of turns out nice. Or just get them equal to the same base and set the exponents equal to each other. And that's kind of the idea. Anybody have any questions on the first one? Because this is the basics of what we're going to be doing. Okay, then let's go to the next example. Let's take a look at example number 2 here. So 2 to the x power plus 7 equal to 10. If you look at this one is not one of those problems now where you can just go through and change these both to base 2. Okay? So we kind of have to go with the second option, meaning step number 1, I need to get the exponential part of this all by itself. Well, the exponential part in this one would be this right here. I got to get the 2 to the x by itself before we can do anything else. So that means we're going to subtract the 7 off to the right-hand side. We end up with 2 to the x then equal to 3. And now we're at the point where we kind of were in the last example, except 2 and 3 are not both powers of the same base. I can't rewrite them both as powers of 2 or anything along those lines. So in this case, I'm going to do it a little bit differently. What I'm going to do is at this point, I'm going to take the log of both sides. Okay, and we're going to use one of our properties we talked about the last couple of days. I'm going to take the log of both sides. So we will have the log of 2 to the x equal to the log of 3. And again, I'll show you 2 different ways to do this one. You can pick which way makes more sense for you. Now, if we take a look on the left-hand side here, what property do we have that'll help me that we talked about in the last couple of days? When I take the log of something to a power, what can I do with that power? We can bring the power out front. And so that's by taking the log, I can now bring the x out front of the log. So now I could rewrite this as x times the log of 2 equal to the log of 3. We can bring that exponent out front. That was our third property that we were working on the other day. And now that the x is down into the problem, now I can solve for it. Instead of x times the log of 2, I want x by itself, so I'm just going to divide out the log of 2. Log of 2's will cancel. And therefore, and now that x is by itself, now you can type in log of 3 divided by the log of 2 right into your calculator. Okay? You can type that in, and you should get an answer of approximately, correct me if I'm wrong on this one, but approximately 1.58, I believe, is what you end up with for an answer. Log of 3 divided by log of 2. Okay, those people that got the calculator out, did I do that right? 1.58, is that right? About, I get, okay. So I'm gonna give you a second option, because one of the properties that I look at a lot of times when you got a variable in the exponent, get the exponential part by itself and then use logs to bring that exponent out front. Okay, that's kind of the idea. We can use that property. However, I could have, at this step right here, once again, I could have used the definition of a log right there. Just like I did back up in this example, I could have rewritten it using the definition of a logarithm. So if I wanted to take that exponential function and rewrite it, I could rewrite it as the log base 2 of 3 equal to your exponent. And now you could type log base 2 of 3 into your calculator and get that same answer. And so if you're thinking about this at all, again, going back to the change of base formula that we talked about over the last couple of days, this log base 2 of 3 and the log of 3 divided by the log of 2, those are the exact same things. Remember, the change of base said you take the log of the argument divided by the log of the base. Well, that's exactly what we have right here. The argument is the 3, the base is the 2, there it is, log of 3 divided by, so either way, you're going to get the same answer, okay? If it makes more sense to take the log of both sides and bring the exponent out front, then do it. If it makes more sense to you that once you get to the exponential part, if you get to this part right here, and you want to just change it into logarithmic form at that point and solve, that's fine too. Okay, whatever. You don't have to do both. You just have to make sure you're understanding one or the other, so that you can go through and solve these problems. Anybody have any questions so far? You pretty much have two options: get the basis to be the same, or this process right here. All right, let's do another one. Let's take a look at example number 3 here. So once again, because the exponential part is not by itself, and what I'm referring to is that term right there, trying to get that piece all by itself. So step number 1 is I'm going to take that minus 3 and add it to the other side. Those will cancel. We get 16 to the negative 2x power equal to 4. And now, once we're at that point, now we ask ourselves the question, can I get these to be the same base? Okay, or do I have to use logarithms or the definition of a log? What do you think? Can I do the same base idea on this one? Yeah, and just as a heads up, if you're going to do the same base, make sure you try to do it the smallest base possible. So even though 16, they're both powers of 4, they're also both powers of 2. So you want to reduce them to, if you're going to reduce them to the same base, make sure it's the smallest base possible. Okay? So what I mean by that, again, I'll show you 2 different methods on this one. 16, we can reduce that to 2 to the 4th power, which is then still raised to the negative 2x. The 4, I can reduce that to 2 squared. And if you now remember back to your properties, a power raised to another power, we multiply the exponents. So this is actually 2 to the negative 8x power equal to 2 squared. And now that we've got the bases the same, the exponents must be equal to each other. Therefore, negative 8x has to equal 2, and now we solve for x. Divide both sides by negative 8, and we find out, if we reduce, that x is negative 1/4. So there's kind of method 1. In this case, it worked out. I can reduce these both to the same base, and therefore we've got our answer. Or again, the second option is, at this point, the 16 to the negative 2x equal to 4, you actually have three options here. You could either go definition of a log and rewrite this as a logarithm now, or we could take the log of both sides and bring the negative 2x out front. Okay, we could use that property. So we actually have kind of three different options, three different ways to solve this. Out of curiosity right now, give me a quick gauge of, as you're seeing this next method, as we do this method, if you had to pick, and I know it's very early, we're 10 minutes in, if you had to pick right now, how many people would do the definition of a log, where you change your exponential form into a logarithmic form, versus taking the log and bringing the exponent out front? How many people, yeah, go ahead and raise your hand if you would do the definition of a log. And it doesn't matter, I'm just curious where we're at. Okay, 3, 4 people. How many people would take the log of both sides and think that they like that better when bring the exponent out front? Raise your hand on that one if that's you. And we got 2/3 of the class who didn't vote. Okay? Just like I said, just curious on which way you're starting the introduction to this of how you're feeling about it. Okay? It does not matter. So if we go through and at this point, because there are more people that raise their hand, if I change this into logarithmic form, we would have the log base 16 of 4 equal to negative 2x. And then from here, divide both sides by negative 2. Log base 16 of 4 divided by negative 2. Well, 16, the log base 16 of 4, if you think about that one, now we got to try to get an answer on that. Okay? 16 to what power gives you 4? Well, this piece right here, the answer to that part, gives you 1/2. So what we actually have is 1/2 divided by negative 2. And if we divide by negative 2, remember dividing by something and multiplying by its reciprocal are the same thing. So dividing by 2, negative 2 is the same thing as multiplying by negative 1/2. So I do end up with negative 1/4 as the same answer. But I wanted you to see where that comes from as well. If once again you like that last method, okay, or you like the idea of bringing that out front, let me go one last quick method here. 16 to the negative 2x equal to 4. If you like the idea of taking the log of both sides, we can take the log and bring the exponent out front, meaning I would have negative 2x times the log of 16 equal to the log of 4. And then the rest of it, now that this is down into the problem, now we solve for x. Divide both sides by the log of 16. You get negative 2x. What you will find if you were to type this, if you were to either answer the question or type this into the calculator, the log base 4 divided by the log base 16, or log of 4 divided by log of 16, that's going to give you 1/2. So that answer is actually 1/2. Divide both sides by negative 2, and we're right back to where we were up above, giving you x equal to negative 1/4, a third different way. Okay, so what I want you to notice is it doesn't matter whether you take the log and bring the exponent up front. It doesn't matter whether you go through and just change it straight into logarithmic form. It does not matter if you can go through and change them to the same base. You're going to get to the same answer regardless. Okay? The one that doesn't always work is the first method. This first method does not always work because you can't always change it to the same base. Sometimes you can, sometimes you can't. All right, here's what I want you to do. Try that one. Try example 4 on your own real quick. We're using whatever method you want. Okay? Whichever one of the methods I demonstrated. And see what you can come up with on that one.
What'd you get? trying to get that. I don't know. It's not. It's just going, but it's like 39. It's not gonna be just negative. You know? Sure. Grandma got it for me.
All right, let's take a look. Now, let me ask the question. Now you should have an answer. Hopefully, now we've got an answer from pretty much everybody, hopefully, because now you've done a problem. How many people, when you did this problem, did it by taking the log of both sides and bringing the exponent out front? Raise your hand. If you did it that way. 3, 4, okay. How many people went straight to the definition of a log and just rewrote it as like the log base 14 and did it that way? Raise your hand on that one. Okay, it looks like there's a little bit more people that have done it that way, where you're using the definition of a log. Again, it doesn't matter. It's not. I'm just curious. It's just me getting feedback on how you're doing it. Because it seems like there's more people going the definition of a log. I'll show you both methods and we'll go from there. So if we rewrite this would be the log base 14 of 5 equal to 2x plus 1. Log base 14 of 5. Well, in this case, the log base 14 of 5, you can actually get an answer. I think it's a halfway decent answer, if I remember right. What is it? What is the log base 14 of 5? What does that equal? What is it, 0.6?
Yeah.
Is it exactly 0.6, or is it something that would be rounded?
I rounded to 0.61.
Okay, so it is something that would be rounded, so it's not as nice as I was thinking. Okay, we'll come back to that then. So for now, I'm gonna kind of leave it alone then at this point. So then I'm gonna just solve the equation for x since it's a rounded answer, which means first step I'm gonna subtract the 1 over. So now we've got log base 14 of 5 minus 1 equal to 2x. And now our final step then, we can divide everything by 2. And in that case, now you can go through and type that into your calculator. That way, the reason I solved it without rounding right away is if you're going to round, I'd rather have you round at the very end, okay, and just round once, rather than round in the middle of the problem and then have to adjust and then work with that rounded answer. So log base 14 of 5, subtract 1, then divide by 2. Just make sure, by the way, when you type this into the calculator, that the minus 1 is not in the parentheses. You're not taking the log of the minus 1. You basically have, if I add parentheses, you basically have that. Log base 14 of 5, then you're subtracting 1, then dividing by 2. And ultimately, what do you get, approximately? What do you get for an answer? I think it's negative something, if I remember right. Yes, Abby, did you get it?
0.109, roughly.
0.109? Okay, yeah, agreed?
195.
Oh, 195. Agreed? Negative 0.195-ish, yeah? Okay, very good. I see some head nods here. So negative approximately 0.195, and there's your answer. Okay? So there's kind of method number 1, where we just go straight to using the definition of a log and then solving for x from there. Option number 2, if you did it the other way, right away, the exponential part's already by itself, so I don't have to worry about trying to get the exponential part by itself. So therefore, I can take the log of both sides and bring the 2x plus 1 out front. So if you did it that way, here's what your work would look like. 2x plus 1 comes out front, times the log of 14, equal to the log of 5. Like I said, in general, what you're doing, take the log of both sides of the equation and just bring the exponent out front of the log, using that property we've been talking about. So then the rest of it is just solving the equation now that the x is down out of the exponent. Divide both sides by the log of 14. Those will cancel. And now we're kind of back to where we were before. Subtract the 1 over. So what I've got is I've got 2x plus 1 equal to log of 5 divided by log of 14. Subtract the 1 over. And then finally, very last step, divide everything by 2. And you should get that exact same answer of approximately negative 0.195. Should get about that exact same answer. What are we doing? Making sense? Because that's pretty much the idea of solving exponential equations. You're either trying to get the same bases and solve the exponent, or if you can't do that, like on this one, 14 and 5, I can't rewrite those as the same base. So instead, we either use the definition of a log, or we use logarithms and bring the exponent out front. But either way, we're using logs to solve it. Anybody have any questions? Anything that we've gone through so far? Anything that's not making sense before we get going here? Okay, so then, what I'm going to give you then is I've got a solving kind of exponential equations worksheet. And again, as always, answers are out on Canvas. I put those out there. It's going to give you a little bit of time here to work. We do have shortened periods today, just as a heads up, because of the fact that juniors are basically finalizing registration today at ELT, and sophomores are getting ready for next week's ACT Aspire. So we do have a shortened period. Schedule is up here, by the way, if you want to take a picture of it. We've got till 8:14 today, so we still have about 15, 20 minutes. But I'll get you the assignment, and you'll have the rest of the time to work and ask some questions.